One of the first things we got to do when we want to build any application is we've got to start with data sets. So we will deep dive into what we want from our data set. Specifically, I'm going to talk to you about how data sets, which are right at the beginning of the keyword spotting pipeline, influence how the model will do. So we need to understand what are the kinds of things that our data set really needs in order to be effective for building a TinyML model that does keyword spotting. What does it mean to build a good data set? We've got Alexa, and then the machine comes back and I say, dim the lights. And let's keep it really simple. The vanilla version of keyword spotting is where it wakes up and listens to command. So it's Alexa, just one keyword. Now, the first thing you got to think about is who are the users of this Alexa device? Is it you and only you? Or is it you and me? Or you and me and my parents who are currently in India, who have a very different way of speaking English because they tend to have a bit of a stronger Indian accent. Everybody is capable, perfectly capable of saying Alexa, but the crucial difference is how the machine interprets that sound or hears that audio signal. We'll look at that in the form of spectrograms later, and we'll see there are subtle differences for the exact same word. Because the machine is just looking at audio signals, it needs to be able to generalize, which means that the data set that we are looking at, the data that we're going to train our neural network on, needs to be really diverse. And we need to be able to understand who the users are in order to build a proper data set. Speech processing may happen in different contexts. Maybe it's in your bedroom and you're the only person that interacts with it. Or maybe it's in a very general device in your living room. And it's got to be able to understand your parents, it's got to be able to understand your grandparents, and it's got to be able to understand you. So you've got to think about who the user set is and what different backgrounds they come from and how they're going to be interacting with this in a different way. And it's extremely crucial because you've got to have a rich enough data that's there to train the model well. Now, the second question is, what do they need? What kind of tasks are they trying to do? Because you've got to make sure that you capture the right aspects into that data set. So for example, earlier I said bake at 350. I used that as an example to say that I want my oven in the kitchen to be able to listen for the keyword bake, right? That's the whole context. And then when it hears the temperature, it sets the temperature at the right level. Well, that's the particular task. So there I need to know that the keyword is going to be bake. And now that's crucial because again, when we're building a data set, if we choose a wrong keyword, right, something that's not going to be differentiable from other words, that's going to get you in serious trouble later down the road. So you've got to think about these keywords, and it might be really simple, but later on, when we get to the nuances of actually going to the pre-processing of the audio signal, you'll realize that the keyword that you choose is actually quite critical because some words are not easy to pick up when using machine learning models because it's very hard to tell the difference. So you might actually have a lot of false positives. So you need to pick the right keyword, right? That's really simple point, but important point nonetheless. Then what the particular task you're trying to solve, right? So this could be the accurate controls in a home, to actuate controls in a home, or play music from your most played songs. You need to clearly define that particular task because that outlines the requirements. And I'll show you an example soon. And then how you interact with the system. Well, the data set needs to look quite different when you are standing in front of your phone and giving it a command where you say, take a picture, right? Or you say camera, and then it opens the camera app. Well, that proximity has implications because the audio signal sound is actually going to be pretty large there as compared to some sort of device, that's sitting in the corner of the room and you've got to listen. It's going to have a fainter signal with noise bumping off the walls. And so we need to consider the user's environment and include a good variety in our training data set. And there are a couple of readings that are going to come up that we will take you through this systematically. The main point here is that you need to ask these questions in order to get the right data set. Then, of course, there are aspects of the real world that make it hard. Specifically, you're not in the same, sort of quiet room where there's an audio signal is always going to be crystal clear. The device, be it in my office right now, it's nice and quiet, but I have kids and they get really loud, right? When that happens, for example, all hell breaks loose, right? So we're not going to be able to record this lecture. Point I'm trying to make is that they're going to be background noises, for instance, and that'll happen. So your data set needs to be it needs to have all these kind of background noises and like these real world characteristics, so that when you deploy the product, the sounds that you're listening for, the model has learned to be resilient against these kind of issues such as background noise. And when we are, so what we are going to do in this course is we're going to use this open source speech commands data set designed by Pete Warden from Google. This data set was designed to overcome these limitations by, with existing publicly available data sets. So back in 2017, 2018, Pete thought really hard, talked to many people, and composed a data set that tries to address some of these issues that I mentioned to you earlier. So let's go through and see what's inside this data set, because you'll be using this data in your collabs. The speech command data set basically has a whole bunch of individual words, right? It's not sentences, it's not dim the lights, it's something like a single word. And so it's composed of a whole collection of words, which I'll show you in a second. And it's got many, many recordings of each word. Think about why would we need that, right? Well, for the exact reason that I was just talking about. Like, there are many people who might be interacting with the device. So you've got to capture the fact that people are diverse. They speak differently, they see things differently, they emphasize things differently, right? So by having a broad distribution of examples in your data set, you're effectively going to try and get the model to be able to recognize all of them. Well, and how did he build this? Well, you need a lot of data. And if you need a lot of data, well, you've got to enlist people. Typically, companies will pay labelers, as they say, right? And they hire an organization that actually does the labeling. Later, when they do the data set engineering, when we do that as another module in this course, we'll talk about some of these issues that have come about doing this. But for now, what Pete did was actually got the community to contribute these example words. Those 1,000 and 4,000 examples of each word, well, the community contributed to it, went to a website, recorded the audio for a given word. And one of the key things is that the data set actually includes background noise, in order to be kind of reflective of real world situations. Again, I said, for instance, in this video, my family is really quiet now because they know I'm actually kind of doing a recording. But in reality, it's like a zoo down here, right? And my kids are screaming in the background all times. Well, the point is you need to have some sort of background realistic audio there so that you can train the network. And the speech commands data set actually has that sort of background noise included in there. So the data set is actually limited, but remember I said keyword spotting is all about limited set of keywords. So to overcome this lack of large number of volunteers and to provide for a effective benchmark, the data set is only limited to 25 keywords in English. But this is enough to start to test algorithms and applications. It also includes 10 other words that are similar to the keywords and cover other English sounds, which is crucial. Otherwise, the model might learn to recognize some background talking versus the particular words we care about. Well, what does the data set actually look like? Here you go. Well, here's a distribution of the words that are in the data set. On the left side, you can see all the different words that are there. And the bars over here are basically showing the number of examples that are there for each of the different words. Well, what we'll see over here is that, this is not a perfect data set, but it's good enough, right? Because some words don't have many samples. For example, words on the top like bird, happy, house, and so forth. There aren't as many examples as compared to yes and no. But that is not by mistake. So often when you think about a particular use case, you tend to emphasize the words that are more relevant to you. And that's actually going on over here, for instance. So here you can see these words are actually more often used words, right? So think of it like, for instance, I have a robot, which you will actually do later in this course. And I want to say yes, no, left, right. And I have some sort of machine where I want to talk to, right? So, well, these are quite pronounced in the data set. In fact, these are the words that we'll actually be using because there's a large sample of them also. Now, typically, for instance, if you're familiar with machine learning, you probably have used large data sets like ImageNet or MS Coco or Kitty. And we're talking about tiny ML here. We're not talking about having data that's broadly able to do, and look over a large range. So we have pretty focused applications here. So like ImageNet, which is humongous. It's a beautiful database of images, of image classification, has over 14 million different images that they're broadly classified to over 1,000 different classes, right? So, well, in TinyML, we are much more focused. You know what your application area is, and then you try and construct the data set accordingly, right? So it's crucial. This is the crucial difference, in data set engineering for TinyML. So keep that in mind. It's focused, but it can't be a tiny data set, right? So it's a focused data set, but it still has to be pretty large and diverse. And therefore, when you look at speech commands, that's what has motivated it, right? There are other speech data sets out there, and for automatic speech recognition, and there are multiple sentences, and that's not what we need for TinyML and for keyword spotting. We need a data set specifically that focuses on commands or keywords. And therefore, that's what inspires Pete to actually put the speech commands in data set together, trying to address some of these questions that we raised earlier. And it's actually directly useful for us now. Now, some of the things you've got to think about generally in terms of data sets is about quality control, right? Garbage in, garbage out, right? So you've got to take care of that. You've got to keep in mind that sounds are imperfect just because of the way the sound propagates through. For instance, right now, I'm talking to you and the sound is actually propagating all the way to the microphone, which is getting encoded in some sort of compressed format. And that's getting pushed over to the HDMI cable on my computer, which is then picking it up and doing a little doing decoding on that, decompressing the signal. Then it's passing it through the filters in order to clean the signal a bit. And then it's recording that and voila, you hear me. So what I'm saying is that there are a lot of complicated processes that are involved. So sound can be quite delicate. So when you're looking at recording data, you've got to think about in that sound clip that you're recording, is it how representative of a real signal is it or not? And you've got to capture the noisy backgrounds aspect that I mentioned earlier. That's really important. And we'll actually do that in the collab later on. And with that said, I'm going to stop here and let you think for a moment why we focused on data sets, right? And ask yourself, what did you learn from this lesson? Collecting good, unbiased data sets is challenging and extremely crucial. You get them wrong, and everything down the application pipeline is a waste of effort. So think carefully, and specifically think about what is unique about building TinyML data sets. So you'll get a chance to collect your own custom data set in part 3. But for now, we will continue working through the ML workflow for keyword spotting.